Hi, everyone. So I have a very difficult spot because I'm sitting between you and lunch. So I hope everything is going to go well. I'm first want to thank IoT Nordics and NordCloud for inviting me to be here today. It's a great honor, and I'm very humbled by that. There's been amazing talks, so for me to be here talking to you is just phenomenal. When I first started to think about this talk and write this talk, I had one thing in mind. It's plant a seed in your head, the innovation seed. So I hope this seed will grow up to the clouds. But if you have problem maintaining this growth, I suggest you go and talk to the folks at NordCloud. They have a booth right here. They are very knowledgeable, and I'm sure they'll be very happy to help you. So why am I here talking to you today? Well, it always starts with a story. And my story started 18 years ago. I was studying electronics. I was just graduated and studying electronics. And by our school was an old factory. And the factory was owned by a man called JP. JP had been making ceramics for his entire life, and he loved it. He used to take his bike to go from his home to his oven. But as he grew older, he couldn't ride his bike anymore. So, and without a driving license, he had to walk. Needless to say that it took so much of his time that he almost stopped doing what he loved. As the school heard of that, we got assigned by a teacher a small project, which was building a remote monitoring station for JP. And back then, CPU and memory was a problem. So after some hard work, working some microcontrollers, we managed, using a current loop principle, to install sensors in the ovens and have the monitoring station half a kilometer away. And the fun part of it is, as soon as we got that up and running, JP started to do new things. All of a sudden, he had more time. He could innovate. A few years after that, I moved to Finland. That was in 2002. And I went to work at the University of Technology in Tampere, and we had projects with Nokia research a lot. And at that time, I worked a lot at integrating the human with the home and the environment. And again, after some hard work at porting some TCP IP stack and the XMPP protocol into some low-power devices, we built some services in which people could add the home and the environment in their chat applications to get updates about what's happening in the home, like humidity, temperature, stuff like this. This is when I got hooked. And the fun part of this, again, is when we built these services, we just had in mind this particular example of managing the environment. But in the research team, people started to have crazy ideas, things we never, ever thought could be done. So building things that are fun and that put a smile on people's face is the reason I'm here today. And I believe IoT and the cloud have the capability to change people's life and to tackle the hard human challenges like water, food, air quality, energy, quality of life in general. Today, in 2017, I'm still playing around with embedded devices, especially Raspberry Pi. I love this little thing. This little thing has more power than what powered the mission to the moon. And it's available for $40 or $50. So any one of you can go and get that and start hacking around. Innovation has never been so close to your fingertips. And this is what I want to talk about you today. I'll first discuss about technology convergence. I'll show you how some customers using AWS and IoT have innovated. And then I'll go through some ideas on why I think we are here today talking about IoT, 32 years after Peter Lewis first published the term IoT. IoT is, of course, not so much one single technology, but more a wave of technology, which comes to touch us in many, many ways, as it's built into the things we buy, use, and love in our daily lives. But IoT has been around for many years. So why, all of a sudden, everyone talks about it? When AWS was launched in 2006, we had 3 services. A storage services called Amazon S3. We had a compute service called Amazon EC2. And we had a queuing service called SQS. And if you ask any hacker or someone that likes to build things, this was pretty much enough to start having early adopters, mostly startup, jumping on the technology. 10 years later, today, almost, we have 80+ services from compute, analytics, databases, a data warehouse, up to machine learning and artificial intelligence. So the cloud as a technology has finally been adopted en masse. And like Jeffrey Moore would say, the chasm has been crossed. A lot of things have converged to make the cloud a reality. But more importantly, it has enough services for people to stitch things together and build ideas that have been sleeping for many years. Now it's easier than ever to build those ideas. Our contribution at that time was the launch of many managed services. Around 2014, 2015. Those managed services take time out of you. You get more time for your business. Services that take the heavy lifting out of you. Services like serverless computing, streaming, database, data warehouse, again. Services that allow you to build very powerful IoT applications. As we all know, IoT is now everywhere in the society. Everywhere IoT helps companies be more successful. But more than that, it comes to touch us in myriads of ways. Let me show you how some companies are using AWS today to innovate. One company is called MyoVision. MyoVision is the world leader in helping government extract value and insight from traffic data. They have over 650 customers. They cover 50% of traffic light intersections in North America. What they do is connect traffic light to the AWS cloud using IoT platform to do device maintenance, but also do traffic optimization. What they do is optimize the time for security and for emergency response team to get to accident scenes. Roadshow is a software provider and creator of an irrigation controller that allows customers to save on water. The irrigation controller consults local weather forecasts and match this with soil type and other data for the agriculture or the consumer to optimize irrigation schedules without having problems of over or under irrigation. One Nordic enterprise that is doing amazing things on AWS is Assa Abloy, the world leader of door opening solutions. What they do is they created a service called Mobile Access Solution, which uses AWS and gives opportunity for hotels to give their guests opportunity to use their mobile device as check-in, but also their mobile device as a door key. With the ambition to connect 20 million cars in Europe by 2020, using the Spark technology, SpringWorks, also a customer in the Nordics, is using AWS because of the scalable service that they need for their developers to push content fast in production. They also use the AWS platform because of the security constraint, which is very important for their partners. One partner of SpringWorks is Telia. Telia is the largest mobile operator in Sweden, which uses Spark as its IoT platform. Telia Sense, the Telia solution, allows car drivers to get information in real time about service and traffic. It also allowed the company to generate new revenue stream by connecting the car owner to services like insurances and car repair shop. Another well-known enterprise doing amazing things on AWS and transforming their organization is Scania, the world leading manufacturer of heavy vehicle. Scania is planning to use AWS for their connected vehicle system, allowing truck owners to track vehicle, but also collect real-time data to do preemptive maintenance and reduce downtime of their truck. Those are amazing use cases. But now, I want to talk about something a little different. I want to talk about artificial intelligence. In 1957, a man called Frank Rosenblatt designed an electromechanical neural network, which he trained to recognize images 20 by 20 pixels. At that time, it was extraordinary. The machine was called Perceptron, which is also an amazing name to me. In 1975, Paul Verbos created an algorithm called backpropagation, which allows faster and better algorithm and calculations of those neural networks, and especially save on computation. So if neural networks have been around for so long, why am I talking about it today? And why there is such a buzz recently about them? Well, let's first see how neural networks work, because this is very important to understand. A neuron is a simple construct that takes and that sums weighted input to produce an output. The neurons are organized in layers. The beauty of neural networks is their capability to self-learn. Given a large amount of data, they are able to produce the best possible answer. The training phase and the self-learning feature of neural network are well adapted to solving informal problems. But there is a catch. They involve a lot of mathematical computation that exponentially increases as the data sets increases, but also as the layer of your neural network increases. This problem is called the curse of dimensionality, and is the major reason why neural networks have been stagnated for decades. There was simply not enough computational power to train those networks large scale, nor there was enough data to train those networks. Neural network need a lot of data to learn properly. The more data, the better. And there was simply not enough data, and it was simply not possible to store and use large amount of digital data back then. A significant breakthrough happened in 1998 with the invention of convolutional neural network, which is a new type of neural network, multi-layered neural network, hence the term deep learning, which I'm sure every one of you have heard about. This new method dramatically reduces the computing costs of network training. By late 2000, three things made large-scale neural network possible. First, large data sets were widely available. Pictures, videos, music, everything was all of a sudden digital. The second is researchers were finally able to leverage the parallel processing power of GPUs simply to train the networks. And last but not least, cloud computing brought elasticity and scalability for developers and researchers to start very large infrastructures to start computation and train those networks. The good thing is those researchers and developers didn't have to pay for the infrastructure, or they had to pay on demand. So they could start thousands of instances and just pay for the time they were used. These three things made, finally, neural network a reality. Today, neural network state-of-the-art neural networks are capable of recognizing images faster and more accurately than humans. 5% for a human, 3% for a neural network. Autonomous cars are a reality. Drones are using AI to fly and deliver parcels. Amazon Echo understands natural speeches and is able to talk back to us. The list of AI applications is growing day by day. When AWS was established in 2006, we made one core premise, which was anyone, even a student in his dorm room, should have access to the same technology as Fortune 500 companies. We call that democratization of technology. And as I said, we have services now that range from databases, data warehouse, machine learning, up to artificial intelligence. And by allowing anyone to stitch those services together, you all of a sudden end up with Aristotle's promise that the whole is greater than the sum of its parts. And that's exactly what you get to the cloud. You can make sense of your data in minutes. You can find new business opportunity that you didn't even know existed. And the beauty of it is that you can start now and in minutes. One person that had an amazing idea is my colleague, Troy. Troy has spent most of his time in the last few months connecting his entire home to the cloud. And in particular, playing with Amazon IoT and Amazon AI services like Amazon Polly, which is a text-to-speech synthesizer, and Amazon Lex, which is the very artificial intelligence engine that powers Alexa for doing conversation. What he's been doing is really connecting his home to the cloud. But why, you may ask? His son, Calvin, on this photo, is autistic. Autism disorder includes problem with communication and repetitive behavior. Oops, I'm ahead of slide, sorry. So Troy put IoT buttons like this one, this little piece of plastic, everywhere in his house, and together with speakers. So every time Calvin goes in a particular room, he can press one of those buttons. And the nice voice of Polly will guide him through his daily tasks, like brushing his teeth, putting on his clothes, eating breakfast. All the daily tasks that are so easy for us, yet so hard for Calvin. Let me show you a little clip from Calvin doing an interaction with Polly.
Now we're in the bathroom, and we're going to help him.
Let's brush your teeth. Get the toothbrush and put some toothpaste on it.
And so now he's going to grab the toothpaste and toothbrush. And you think about someone, again, who is living on their own downstairs in an in-law suite in the basement or in a separate guest room. This gives them a sense of independence without having to have a physical person in the room with them all the time.
Okay, now brush your teeth.
Unfortunately, Polly can't make toothpaste taste better.
So thanks to Polly, Calvin is now a lot less stressed. He's a lot more relaxed. And especially, he has a lot less panic attack because Polly has a familiar voice for him now. The quality of life of this family has dramatically improved. And Calvin is learning at a faster pace than ever before. But why am I telling you all that? Well, until recently, it didn't strike me that those little piece of plastic, this IoT button, could save someone's life. And in fact, it cannot change and save someone's life. But connect that to an ID and bring that ID to the cloud. And all of a sudden, you open up its capability. You make the impossible possible. You're now probably wondering how to get started. Well, according to Christensen, who is the father of disruptive innovation theory, no idea for a new growth business ever comes fully shaped. When it emerges, it comes half-baked. And then it goes through a process of becoming fully shaped. What this means in practice is prototype, test, get feedbacks, and iterate fast. Prototyping, like my colleague Troy, has never been easier in the cloud. Prototyping is about acting before you got all the answers. It's about taking chances, stumbling a little, and then making it right. Prototyping is about connecting the dots. And this is the cloud revolution. And this is why so many disruptions have happened in the past few years. Disruption of entire industry. Hotels, automotive, manufacturing, retail, banking. Every single industry is facing stronger than ever competition. So what's about IoT and artificial intelligence, and why did I even talk about it? Well, smart people have already started to embed artificial intelligence engine like MXNet into devices like this. This IoT device, this Raspberry Pi, is now AI-powered and can recognize things around it. It can learn. And I can bet you it's not going to take long until it's ported into those devices. And then someone, probably in this audience, will connect the dots. And then something amazing will come out of it. So I want to leave you with one question to discuss over lunch. And then I promise I'll stop. How can IoT, combined with artificial intelligence connected to the cloud, can help you grow your business? But especially, how can it help you stay competitive against this one person in a garage, connecting dots, hacking things together, and ready to be your strongest competition ever. Thank you very much.